Hello everyone. So in this video we'll see the first practical, that is 1D bar element structural analysis, structural linear analysis, and the description is that is a steel bar of cross section 100 square mm and the length is 0.5 meter is fixed on one end and the other end is load is applied, that is 10 kilonewton, and assume that the material bar and the material is given, that is structural steel, and you have to find out total deformation, stress, strain in the bar due to the with the help of FEA software. So FEA software where we are going to use, that is ANSYS workbench. So first of all, go to the static structure, pull the static structure here, and in the static structure we can give the name of the project, that is 1D bar. Okay, this way you can give the name, and see first in static structure, that is the engineering data. So in engineering data, if you double click on it, so you will see we have to select the type of material. Okay, so in the numerical, the type of material is to be select material selection, that is structural steel. So by default the structural steel is selected, and if you want to change the material, you can click here and give data of that material, such as, if you see, take an example of structural steel, that is density, okay, tensile yield, means Poisson's ratio, Young modulus. So such a type of data should be given for the material. Okay, so after that, cut this, and next step is geometry. So if you double click on this geometry, so it will take a specific time, open the new window. Okay, so this is modeling window. Here you can create the objects. Okay, so what is given in the numerical? So a steel bar cross section of 100 square mm. Okay, so unit is given, that is mm. First of all, you have to select the unit, and the length is also given 0.5 meter. So your unit is there. So unit which is given in mm, we'll select the mm. Next, click on XY plane, right click, look at. Okay, so I will select XY plane for the modeling. Next, for sketching, here we have to create a rectangular block. So for that I will select the rectangle. Okay, rectangle on this axis midpoint I will click. Okay, so one point will be here, and next I will select second point. Okay, now the model is created, so a rectangle is created, so dimension is required. So click on dimension, click on general, click on one line, okay, horizontal line, and click on vertical line. Okay, so this h1 v2, so this dimensions is seen here. Okay, and we can edit these dimensions. Now dimensions which is now in numeric it is given 100 square mm. So 100 square mm, so the dimensions will be 10 horizontal and 10 vertical. So 10 into 10, that is nothing but 100. Okay, so this 2D drawing we have created. Now we require to convert this 2D into 3D. So the length is given, that is 0.5 meter. Okay. So in this, for that we have to extrude. To convert this 2D into 3D, we have to click on this extrude. Okay, so it says that which geometry you have to select. So by default this geometry is selected, apply it. Okay, and next depth is nothing but the length, whatever the depth is required. So this, the length is given, that is 0.5 meter. So if you convert into mm, dimensions we have selected, that is 500 mm. Okay, then click on generate. So automatically this 2D is converted to 3D. Okay, so this is 3D model what we required. Okay, now we have created our model. Now next step, minimize this. So if you see here, one click is there, so green click means our model is ready. Next step, geometry is ready. Go to model. Here again it will require a specific time to open. It's depend on the configuration which you are using. Okay, so whatever model we have created, it is appeared here. Okay, next step is meshing. Meshing is nothing but to create this part, one of the objects into number of elements and nodes. Okay, so right click on this mesh, just click on generate mesh. Okay, so mesh is generated. You can zoom this with the help of this. Now you can also change the elements. If you have to change the element size, you can right click on this, insert, click on sizing. Okay, so here the element size can change. Here the by default, first of all select the object. So for that, to select object, you can click here for body selection. If you select this object, apply. Okay, throughout we have to change the element size. Here 5, element size is 5 mm. Okay, and again just right click on generate mesh. So see the changes. Now the elements size is 5 mm. Okay, more the elements size, if size is less, accuracy will be increased. Okay, in statistics you can see the number of nodes and number of elements. Okay, now this step is over. What is next step? Next step, you have to give the boundary conditions. Okay, so in boundary condition they already said that one end is to be fixed and second end 10 kilonewton force is applied. So for that, for applying the boundary conditions, go to static structure. Okay, here you have to insert, first is a force which is to be applied on one face. So I will select the force. Okay, and select the face. For that, if you have to rotate the object, click on this rotate. Okay, so I will select this face. Okay, for selecting the face, click on face, select. Okay, apply, and see what is, that is 10 kilonewton force is applied. So 10 kilonewton force which is applied is acting. Okay, for that, just a minute. So here vector is there. Instead of vector, you have to select the component, okay, and you have to apply the force in this axial direction. So axial direction is z direction, okay. So z direction, you have to put the value in z direction. The value will be so 10 kilonewton is nothing but the 10,000, okay. And if you see, you will see that is a compressive force is applied, but we require tensile force. So for that, instead of in front of 10,000, you have to just uh, implement a minus sign, negative sign, so the direction will be changed, okay. So now first load is applied. Now second boundary condition, that is you have to fix one part force is applied and one part is to be fixed. So I will select the fixed support here, okay, and the fixed support is should be given to the other face. Select the face, this face. So geometry is selected, okay. So automatically this part will be fixed, okay. So if you see, if you click here static structure, A is nothing but the force is applied and B part is fixed, okay. Now next we require the solution which is to be found out, that is first one, insert deformation, total deformation, okay. Next solution we require, that is stress equivalent 1 minus stress, again insert strain equivalent 1 minus strain, okay. So these three results we require. After that, right click on solution, just solve it. Again it will take a specific time. Okay, so this green tick is nothing but your solution is done, okay. Instead of this green tick, other ticks will be there, then there will be some, you might be said there is some problem in the analysis, okay. So if you just click on this total deformation, so maximum deformation and minimum chart is seen here, okay. So maximum deformation is, that is 0.249 and unit is in mm, okay. So that is in here the area where the maximum deformation is seen. You can click on maximum and minimum probe. Here you can see that, see, maximum deformation is on the where the force is applied and minimum deformation is where the we have fixed it, okay. So this is total deformation. Equivalent stresses, if you see, maximum stresses is generated in this area where where the beam was or this bar was fixed, okay. Where it was fixed, there the maximum displacement, maximum equivalent stresses is developed. And you can also see the strain. And if you want the animation, then you can also get just click on this graph. You can see the animation or simulation, so how the deformation equivalent stresses are developed as the force is increased, as the time is changed, okay. So I hope you understood the first experiment. So thank you, thanks for watching.